Good afternoon, everyone. Thanks for joining us today for DataBytes with the National Consortium for Data Science. My name is Amanda Miller, and I'm the Associate Director for the National Consortium for Data Science. I want to extend a warm welcome to all of you, and first, provide a bit of context. The National Consortium for Data Science, or NCDS, is a project of the Renaissance Computing Institute, also known as RENC, at the University of North Carolina at Chapel Hill. Every 2 months, NCDS hosts a free learning opportunity, often addressing AI in some capacity. Today, we're thrilled to host Sophia Rowland from SAS Institute. Sophia is a senior product manager focusing on ModelOps and MLOps at SAS. Before we begin, I'm going to share just a few housekeeping items. We have disabled Zoom Q&A for attendees. Chat is also disabled to allow Sophia to present without distractions. However, we do offer a place for you to share your comments and questions. All questions and comments should be uploaded to Easy Retro, which is our crowdsourcing Q&A platform. I'll share the link in the Zoom chat in just a moment. You are welcome to add your questions and comments as Sophia moves through the presentation. We'll also share instructions and the link once again before we begin the Q&A. If we don't get to your question during the event, we will address it in our wrap-up materials. So, without further delay, Sophia Rowland.
Thanks, Amanda. Good afternoon, everyone. My name is Sophia Rowland, and I'm a product manager here at SAS. And I've been working alongside our data ethics practice and trustworthy AI team here at SAS to help develop a workflow that combines the AI risk management framework from NIST with the analytics lifecycle. And today I really want to chat about how we mapped the AI risk management framework to the analytics lifecycle. For today's session, I of course want to start by introducing the AI risk management framework from NIST, discuss how we did that mapping, and end with some resources where you can learn more. The Trustworthy AI workflow is a workflow that we've designed to work within our end-to-end analytics platform called SAS Viya. But today, I really want to focus on the core concepts we use to develop that workflow and share resources and documents to aid the adoption of the AI risk management framework, even if you aren't using SAS Viya. To start, we know that AI usage is all around us, and we know that isn't going to change anytime soon. For example, there was an event called Willie's Chocolate Experience a few months ago in Scotland, and they used AI-generated images to advertise that event. And here is one of those images pulled directly from their website. And if you read the text in this image, you can see that attendees to this event were promised catting and Karchi tons, among some other very interesting advertisements there. And unfortunately, attendees noted that this event looked nothing like these AI-generated images. There were no catgatting, there was no Karchi tons, and folks have been able to laugh it off after demanding their refunds. Here's a case that's a little harder to laugh off. It is from this past February, where a court in Canada ruled that an airline has to provide a refund to a customer when their chatbot, based upon a large language model, hallucinated an answer. It provided an incorrect answer that was inconsistent with the airline's bereavement policies. And now we know that an inconsistent or a hallucination from a chatbot can be worth up to $812 in this case. And here's a case that's worth a bit more than $812. It is from February before last, and it was when a woman who was arrested out of Detroit based on a match in a facial recognition technology. Now, there were two major issues in this woman being arrested for this facial recognition technology match. And one was the photo they had of the woman was 8 years old. And at the time, this woman was visibly 8 months pregnant. I don't know if you've tried to commit armed robbery while 8 months pregnant, but it's near impossible. And the description of the suspect said absolutely nothing about being very visibly 8 months pregnant. Ultimately, someone should have stepped in and noticed that the facial recognition technology absolutely did not take into account pregnancy. And so this woman is suing the city of Detroit for this false arrest. We know that AI usage is all around us. And that unfortunately also means that the irresponsible use of AI is all around us. And the irresponsible use of AI, it incurs a cost, even if it isn't always a financial cost. As such, there are organizations worldwide that are striving to develop standards and best practices around the responsible use of AI. Here in the US, we have one such organization called the National Institute of Standards and Technology, also known as NIST. And they have created the AI risk management framework to improve the abilities of organizations to incorporate trustworthiness considerations into the design, development, use, and evaluation of our AI products, services, and systems. Now, this risk management framework includes several recommendations that are based within these four categories here: govern, measure, manage, and map. And as you read through the AI risk management framework, you'll find that several of these recommendations are what I would classify as organizational capabilities. They are capabilities that should be organizational wide, but many others are based specifically on building out and maintaining AI systems. And that's where we're really going to be focusing on with our recommendations baked into the analytics lifecycle. And we at SAS specifically selected this framework because it is one that is so well developed, so well thought out, and it is one that we foresee as potentially becoming a global standard in this space. So we do have a quote here from our vice president of our data ethics practice, Reggie Townsend, just really iterating the point that this is a framework that has received acclaim and is one that we are very happy to make available within our platform. So what we've really done is to take these recommendations from the AI risk management framework and map them to activities within analytical projects in the analytics lifecycle. Now, if you look at the analytics lifecycle, ultimately it describes a set of repeatable overarching processes that analytical projects tend to take. For example, analytics projects tend to start with a question, a goal, a business problem that we're trying to solve. For example, it might be something like, if I offer this individual a loan, will they pay it back? Will someone click on this particular ad if I put it in the sidebar of a website? With my very limited budget, where can I best direct services and resources to be the most beneficial? Analytics, it's driven with a purpose. And by making these better decisions, we really are focused on improving a particular outcome. So we have our question in hand. Next, we need to start pulling together the tools to answer that question, to optimize that outcome. So we start with data. We need to access, prepare, and pull together various data sources. We use that data to develop models or other analytical assets such as dashboards. And the last piece is really aimed at getting these models, these assets into a place and form where they can be used to make those decisions and ultimately improve this outcome. So for example, if we might develop a model that tells you what is someone's chance of defaulting on a loan, or we might develop a model that looks at the propensity that someone will click on the ad. How likely are they to click on that ad? And then we can look at getting them into a place, a form, and a location where they could be used to make these decisions. Could I have my loan officer see that probability of default as that application comes in so that they can decide whether or not to approve that loan. Could I have a website that automatically chooses the best ad to serve in the pane based on how likely an individual user is to click on that ad? Or maybe do I need to create a dashboard or report that my leaders in my organization see on a regular basis that helps them decide where to direct resources? And this is ultimately a cycle because our world is ever changing. Models, AI, analytics, they ultimately represent patterns that they discover in their training data, patterns that show these relationships in the world at a specific time point. But these patterns and these relationships, they don't hold true forever in our ever-changing world. So that ultimately means that our models, our AI, our analytics, they become less effective over time. And to combat that, we have to continuously monitor the system and make those updates whenever we notice that there is degradation in our analytics, our AI, our models. So what we've done is to create specific steps within this overarching analytics lifecycle to address these key recommendations from the AI risk management framework. And so these include steps for identifying the project stakeholders, generating and compiling key documents for the project, preparing and assessing the data, preparing and assessing our models, comparing and validating among our models, testing and putting those models into a production environment where they can be used for decision making, monitoring them over time to ensure that they remain effective, and having an ongoing audit of that project. And again, this fits very well within the overarching analytics lifecycle, where we start by defining our teams, defining our project goals, preparing and assessing our data, developing our models, comparing our models against one another, ensuring that our models work for our use case, and then putting those models into a production environment where they can be used to affect decisioning while monitoring them over time so that we know when it is time to start back to gather fresh data and start the process all over it again. Now, what we ultimately want is a production model with the documentation to support the assertion that the organization's done its due diligence. They provided evidence that the model is fair and that their processes do not cause harm. And after we've done this mapping here between these steps to the analytics lifecycle, we defined a process around how to address our AI risks. The process tends to take this form. First, identify the risk based on what we see within the AI risk management framework. Next, make suggestions to mitigate that risk and show those suggestions to the appropriate stakeholder. They can ultimately choose to implement those suggestions. They may choose to take another route, or they can choose to move forward and provide documentation or justification for why they need to do so. Ultimately, how you mitigate or address a risk is really dependent on the goals of a specific project. But the last piece is to have that checks and balance in place. Have a decision maker for the project decide if what the stakeholder did is valid, is something that we're comfortable and happy with. If so, we can move forward. Otherwise, our model owner, also known as our decision maker, has the power to move back and have the stakeholder address that risk again. So ultimately what we have now is our AI risk management framework. We have these recommendations. We've organized them within the analytics lifecycle, within processes for how to address these specific risks. And what we used was the tooling available in Sophia, and here's a picture of our workflow that we developed, which features user tasks, which are approvals, tasks that we want an individual to perform, documentation that we want them to compile and generate, and pretty much anything that you want a human in the loop to do. We also have system tasks, which are tasks that can be automated, as well as branching, so we can move back to another section of the workflow if we need to. But for folks without Sophia, we do provide a Word doc along with our workflow that is freely available with all of our user tasks listed out to really help you get started as you start to adopt the AI RMF. Even though with the Word doc, you will lose some of the automation, but it is a place that you can freely get started. Now, for the bulk of our time together, I really want to focus on the main steps here of our workflow and address what we cover in each of those steps. So the first piece is to define our stakeholders. We know that analytics is a team sport, and there is important insight spread among multiple individuals. Now, we've identified 6 key personas holding these important insights. This includes the individual with the decision-making power of the project, referred to as the model owner. We have our data scientist who trains or builds our model. We have our data engineer who prepares our data, our MLOps engineer who puts that model into production, our model risk owner who manages and documents the model risk, and our domain expert that provides that business or domain expertise for the project. Now, important to note that at some organizations, these different personas may be 6 different individuals, or maybe even 6 different teams. Other organizations, this entire set of personas may only involve 1 or 2 individuals. But we really want to start by understanding where these responsibilities lie before moving forward. So the next piece is to ask these individuals, ask these personas to centralize their project knowledge. So we've organized the tasks at this point based on these personas. So putting together this documentation, it really is helpful for defining that project itself, the purpose, the usage, the limitations, the thresholds for action, and much more. Compiling this documentation in a centralized self-service location also makes transitions much easier should you have someone roll off this project or someone new come onto the project. So we start with our model owner. Remember, this is the decision maker for the project who holds that decisioning power. And they start by defining the goals, the usage, the preferred metrics, feedback strategy, and more. Our data scientist taps into their statistical acumen to understand a bit more around the statistics of the project. So if our model owner says this is the metric that we want to use for assessment, perhaps our data scientist will come in and say, well, that's the metric you want to use. Here's how we interpret the values of that metric. And here is what an assessment for a threshold would be. Our data engineer really looks at the data and understanding the data itself. They're really going to be good about having data about data, the various metadata, whether that's this data set includes personally identifiable information. This data set has this specific time period that it covers. All really great information that we need to compile. Our MLOps engineer, often at some organizations, IT resources, they understand how best to get that model, that analytical asset, in a location where it can be used to affect decisions. So for example, it may be scoring transactions ad hoc, real time. And so there's downstream data feeding into the model and upstream processes making decisions based upon the model. Other use cases may show that the model is scoring data in batch on a scheduled basis. Ultimately, how that model is deployed relies on the purpose and usage of the project. Now, our model risk owner, they're the ones who understand potential negative impacts of when models go awry, and they look at documenting those risk tolerances. And then our domain expert is the individual that understands the business problem, understands the use case, and they're there to help support and have alignment among these teams. All right, so we've defined our stakeholders, we've defined our project. Let's start getting into the meat of the analytics lifecycle by looking at our data. So our data engineers, they are preparing data, bringing in data from different sources, and some concerns that we might want them to look at is data privacy and data bias concerns. So we want them to look at personally identifiable information, protected classes, proxy variables, and how well the data represents the target population, meaning how well does this training data represent the data that, or represents the population that the model will be used against. And again, we suggest actions to mitigate or reduce these risks. Sometimes these risks are unavoidable. Sometimes these risks are a part of the project. So we just ask users to justify should they need to, so that we have that documented, that we have that decision noted. For example, with data privacy, with data bias, some things we can do are removing problematic variables. masking personally identifiable information, collecting data differently, creating different data samples, or even creating synthetically generated data. So we have a few different pieces that we can do to address some of these concerns. Ultimately, the options that our data engineer and our decision maker, our model owner decides is going to be dependent on our project goals and our use case. So we ultimately want to leave it up to them for them to decide what's best. So now we have our analytics-based table prepared, and our data scientists or our model developers are building their models against that data. Typically, they are assessing those models on performance using various different metrics that are going to be very dependent on the type of model. But other pieces that we want those data scientists to look at are assessments for bias and fairness, as well as assessments for explainability. So we do have a few suggestions for measures and methods that the data scientists can employ to assess data bias and explainability. But again, at the end of the day, the choice is theirs based on their needs of the use case. For example, you may want to look at a specific protected class variable or a sensitive variable that, while it may not be an input to the model, it is data that you've collected and is available. So for example, you might not have gender as an input to your model, but it may be data that you collect. And with that data, you can start to see if your model predicts differently on men and women. Does my model predict that a woman is more likely to default on her loan than a man? What are the implications of that? We can also look at accuracy. Is our model more accurate on white individuals than Black individuals? It's important that we start to note that so that we can take action to reduce those biases. Explainability and interpretability, they are very important for understanding how your model is making a prediction. There are some models like regressions or decision trees that are inherently explainable, meaning that you can easily see and understand how your model comes together, how your model uses those input variables to make a prediction. For the use case of regressions, there is a form of the equation that shows you how much each input variable is weighed when you're making the prediction. For decision trees, you have a series of Boolean if then else statements that you can analyze to see how an input flows to arrive at the prediction. There are other models like neural networks, gradient boosting, or random forest that are not easily understandable. And so we do have a variety of methods that we recommend for understanding how our inputs into the model lead to a prediction. Ultimately, if you can understand how your model is working on some level and you can explain how your model works, you have a much easier time determining if your model is behaving in a fair manner and explaining that to others than if you simply do not understand what your model is doing and it's a black box to you. So up until this point, we've asked individuals to do some additional work, but from this point onward, things start to get a little bit easier because we have put in the groundwork to make the next steps flow a lot more smoothly. So the information that we've collected alongside other key pieces of metadata from our data scientist, from our data engineer, it's used to select what we term the champion model. This is the model that is determined to be the best model, the best analytical asset to optimize the outcome we want to for this particular use case. And we might also define a few challenger models. These are models that might not perform as well as the champion model, but they are still pretty good models that we want to keep in our back pocket. Now, how we decide our champion model goes back to the documentation we have compiled earlier. When we looked at what our assessment metrics were for determining the best model, this is where it flows in to make that decision. So work is getting much easier because we've laid in that groundwork earlier. So with that champion model in hand, next we execute our testing plan. Again, we documented what our testing plan was earlier, so it is clear and understandable for our data scientists and our MLOps engineers to start this task. And once our model passes those tests, our MLOps engineer can deploy that model, put it into a production environment where it can be integrated into our business processes and really start to affect the decisions that we make so that we hope to make more accurate decisions, better decisions, and start optimizing our outcomes. Again, models are developed on our ever-changing world, and so our models are becoming less effective over time. Models don't all decay at the same rate, but we do see that models are decaying over time. And this means that we need to monitor our models over time to ensure that they remain effective. We need ongoing performance monitoring, and we need to note that threshold for action from our documentation earlier so that we know when it is time to take the next step. Performance monitoring and alerting based upon our thresholds, they are things that while an organization can start by doing manually, it is something that is becoming more and more automated as organizations start to mature analytically. So once we have our thresholds in place and we know when it's time to take action, it's up to our users of the workflow to decide what is the best action. They can start by looking at their challenger models. Did our challenger models experience the same degree of degradation as our champion model? Could we validate that a challenger model is working better than a champion model and put that one in production instead so that we can just quickly do a swap? Perhaps we have a batch of fresh data available and we want to retrain and rebuild our analytical assets so that we can continue to remain accurate. Perhaps we want to continue and reevaluate at a different time point. Or perhaps it's time to retire the project altogether. And the last piece that we recommend as a part of the workflow is to audit the project on a recurring basis. This helps ensure that our contacts, our specifications, our limitations, they're all still the same. So we can ask, are the people attached to this project still here? Did anyone leave? Does anyone need to be onboarded? Is the documentation, the limitation, the goals, is that still the same? Has anything changed with the data? Is there new data available that we want to leverage? Are the specifications that we set for our model still valid? Or are there potentially new models that we can leverage? And the last piece is this project still useful? Now, this is a best practice that I do recommend in general, because as I've worked with many organizations, many of them have models in production that they're simply not using. For whatever the reason, the project has no longer been used and that production model is still up. And production models, they have a cost to run, they require infrastructure, they require security. And so it's just an unnecessary cost to keep models in production that you're no longer using. And again, I just want to call it out because this is a common problem that I see at many organizations. So if you need a reminder to audit your production models, this is it. So this workflow, it was designed to be very comprehensive for enterprise AI efforts. So we tried to address every possible which way that we can. And if you are a SaaSFI user, we would love to get your feedback on the workflow. But if you're not a SaaSFI user, we would love to get your feedback on the document that we apply with it. And I'm just going to quickly show you what that looks like. So when you download the workflow from our GitHub, we do have this companion document that is freely available for you to use to start filling out as you work through your trustworthy AI processes. So you can see it follows very similarly along with what we've talked about today. The first step is to identify the model owner, who is the individual that is the chief decision maker for it. And we do within our user task note specifically which guideline from the AI risk management framework we're referencing. So this one aligns with measure 2.8. And so the model owner is then asked to identify the other stakeholders in the project. And from there, those stakeholders start to fill out the various pieces of documentation. So this document is freely available regardless of whether or not you have SaaSFI. This giant QR code here, it will take you to an article detailing the workflow instructions for those who are interested in getting started. It'll also take you to a place where you can start to download that workflow. And again, we absolutely want your feedback. We want to make sure that this is something that makes trustworthy AI easier to adopt. So please let us know what you think so that we can continue to iterate upon this and make it much more helpful. I want to thank you all for joining today. If you want to connect with me on LinkedIn, I have this QR code here. Um, if you need any additional resources, please, you can send me a message on LinkedIn. I'll be happy to share these resources with you. And I think it's about time to flow into the questions. So I'll leave it over to Amanda.
Awesome. Thank you so much, Sophia. You did an amazing job. Really appreciate all your hard work on that. And I'm looking forward to some really good questions today. So in just a moment, we are going to share the Easy Retro board with you. We love this platform because it is pretty easy to add ideas. You simply click on the plus sign in the relevant column and type your idea. When you are finished, you hit the blue box with a thin white check mark to save within the same field, and your idea will appear on the screen for the public's reaction. So you can use this QR code on the right to add your questions and comments. And you can also upvote on someone else's idea using the thumbs up icon. And you can comment on an idea using the quote bubble icon. So, Sophia, do you want to go ahead and hop over to the Easy Retro board, please? There we go. So hopefully everyone will understand these instructions a little bit better. There is a plus sign that you can click on to add your questions and comments, and upvote the comments and questions that interest you using the thumbs up and bubble icon. And with that in mind, do you want to move maybe from left to right, just across the top row, Sophia?
Sure, I can do that. So I'll start with the first question here. How can I convince my team that we need to adopt trustworthy AI? When it comes to convincing others for adoption for trustworthy AI, I really like to look at, and I know this sounds a little pessimistic, what could go wrong? What are the unintended consequences? What are the unintended costs of us creating a system that causes disparate impact, that causes harm? Is there a financial cost that we can document? Or perhaps there's a human cost that we need to consider. I know I tend to take a little bit of a pessimistic approach, but there are so many use cases that are available of irresponsible AI systems. You can do a quick Google to just see all these different instances where AI has been used unethically. And you don't want to be one of those use cases that appear. So I think there is just a uh, bounding source of evidence that what are the costs that you can easily use to validate that perhaps you need to be looking at trustworthy AI in your team. One of the first books I read that really kind of convinced me to move towards trustworthy AI as a data scientist was Weapons of Math Destruction by Kathy O'Neill. There's a lot of really great and eye-opening use cases that kind of help follow along, beyond the machine learning model to how that model is used and what harm it can create. The next question I see here is how do you show evidence of trustworthy AI? So unfortunately, we can't show with 100% certainty that our systems are completely unbiased, our systems are completely fair. The best we can do is provide evidence and support that we are taking into consideration best practices, that we have done our due diligence, that we have documentation, that we show that, hey, this is what we've done, and here are the results of that. So with our workflow, we did list a few different assessments that you can do. So things like looking at the representativeness of our data. Can we say that the data that we've trained the model on represents our population? This is very useful if you're looking at data that's going to be applied to individuals. So if you've only collected data for white individuals, but it will be applied to a whole spectrum of individuals, that's not necessarily a great look. But if you can say that, hey, the data that we trained the model on, the distribution of the population is a pretty close match to the population it would be applied to, that would be really good to include in the documentation to show that your model is fair. There's also metrics that you can look at to calculate, so like metrics that you can look at to calculate whether or not your model is treating groups differently or is accurate on one group versus another. And these were ones that we did include in the slide. So it was, I've lost my board there for a second. So this would be things like the parity metrics. So things like predictive parity, equal accuracy, equalized odds, equal opportunity, all very important pieces that we could compile and store with our model. So let me go ahead and make sure I pop that back up for y'all. The next question, what effect will the NIST framework have on existing NIST security standards? I will say I do not represent NIST in any form. So that might be the best question, a better question for them. But from what I've seen from the AI risk management framework is that there is pretty good alignment between security and AI ethics. I mean, AI ethics does also rely on some security best practices. You don't want to have someone's personally identifiable information floating around if you don't need it within the model. So I think they're pretty well aligned, but ultimately, I think that's a question for NIST. Sorry, my throat got dry there for a second. All right, let's see. I do see an upvote on this question here. And this one says, what is an ideal time frame for regular monitoring of models? How should small companies adapt to this need? And I would say that this is very use case specific. There are some instances where you don't know the ground truth. You don't know the actual value for months. I think there are use cases in financial services where you might not actually know for years whether or not someone defaulted on their loan. So sometimes they do things like look and see if I've defaulted within this 30 days or this 6 months. And there are other use cases that you know instantly or you know within minutes. I know whether or not someone clicked on an ad before they navigate away when they navigate away from the page. So it is really use case specific. I would really, for smaller companies who are really stepping into this space, I would say focus on, again, starting small. Sometimes I need to look at how the process of performance monitoring goes. I need to sometimes manually go through this process for the first few steps. And once I understand it, then I can start to look at automation. Because for live monitoring of deployed models, for performance monitoring of models, it is a mature analytics process. You have to be able to pull data into a location where for performance monitoring, you have to compare it with the ground truth. So I would really focus on, starting small, whatever that means for you, and then building up over time rather than saying, I have to monitor my models every week. Just start at a place where you feel comfortable and move up. There's an upvote here. Are there additional considerations for the adoption of generative AI? Generative AI is an interesting use case because there are several different versions or several different types of generative AI. We, of course, have large language models. We have synthetic data generation. I think that ultimately we want to approach these use cases with the same intention, but you do need an understanding that sometimes because the technology is different, there are different metrics or different specific considerations we need to consider. For example, I had a chatbot example that showed a chatbot that hallucinated. It was based on a large language model. It provided an incorrect response, and it cost $812 for this individual. So ultimately, that is a case where a machine learning model was wrong. And that could apply to almost any machine learning model. They're not going to get it right 100% of the time. So just understanding what happens when things go wrong, what are the costs, what are the feedback mechanisms? How can end users that are being affected by these machine learning decisions tell us or get back in contact with the organization. So for the case of this chatbot, they ultimately had to sue to get their $812. That's probably not ideal. You probably want to make sure that you have a mechanism that comes back to it. So this workflow was really designed with more tabular data in mind for more traditional use cases, but I think a lot of the intention is still the same. It's just going to need to be an extension of it. All right. Um, do we have time for one more question, Amanda, or is it about time to close?
Let's see. I think we have time for one more question if you can make the response brief.
Sure.
Thanks.
I'll take this one. What capabilities does your workflow need? First and foremost, I think you just need, we designed a workflow using the tooling we had available, which has user tasks, automated tasks, branching, different navigation methods and timers. For the first phase, user tasks, you need to be able to have some mechanism for routing different tasks to users, having it assigned to specific individuals, having a place where they can complete it. With ModelOps, with MLOps, I always want to focus on getting the process right first before we start diving in and start automating things willy-nilly, because you might automate something that isn't very meaningful. You might automate something incorrectly. It might create more work for individuals. So I think starting, you just need a way to route user tasks to specific individuals. And from there, once you're comfortable with it, you can start to look at automation. All right.
Great job. Thanks so much. We can forward to the next slide. Sophia has also become my slide forwarder. You guys didn't know she had that title. It has been such a pleasure to have you on today, Sophia, and thanks so much for our incredible audience for attending. We have dropped the book that Sophia recommended in the chat on the side of your screen. Take a minute to complete the eval at the end. And if you are interested in becoming a DataBytes speaker, or you know someone who should be a DataBytes speaker, go ahead and submit that interest form. And Sophia, if you want to forward to the next slide, I'm going to tell you guys about a couple of our upcoming programs. Our next DataBytes will take place on Thursday, June 20th at 4 p.m. And we have the CEO, the co-founders of Grant Scout presenting on how to use generative AI to win STTR and SBIR government grants. Should be a really great exploration with them. And next slide, please. In the very near future, we have Amy Hemmeter leading us through a half-day course called Introduction to AI. It's part of our Foundations of AI series. So do take a moment to check that out and register as well. And then in our very next and last slide, we have some exciting courses. This series is in its 10th year and 11th season. We have been producing this event for quite some time, and Data Matters offers a variety of 1- and 2-day classes, including some Python courses, some basics of R courses, and several more. We have a total of 15 classes that will take place between August 5th and 9th this summer, and we would love for you to check those out. Thank you so much, everyone. I have gone an entire minute over. I very much appreciate your time today. And Sophia, thank you so much. You've been amazing. All right.
Thank you all.
Take care, everyone. Have a great rest of your day.